Hiya, welcome back to Fransham Forge YouTube. What I'm going to do now, I'm going to do a short little film to help everyone because we're dealing with new technology and a few people have had problems on a few of our machines, but mainly other manufacturers' machines as well, because this is all new to people, although it's been out a long time. But I want to go through some of the troubleshooting you get on induction heating. So what I'm going to do in a minute, I'm going to pipe in some induction heaters and I'll show you some things. Now I'm going to put these two heaters in. These are our new Forge Force induction heaters. The other thing that will be coming up soon, which I'll show you but I won't do now, is we're now selling welding sets. British, made in England. Welding sets for blacksmiths, 240 volt. They're nice little welders. I'm going to be trying these out and then I'll film them so you can have a look. The other thing off the same British company is a little plasma machine with a built-in compressor and it cuts 10mm plate on a 240 plug. Really, really smart machine. Later on I'll be doing a little film on that so you can have a look at that as well. And then you can find them on our website if you want any more information. Right, if we go through to the forge. Right, what I'll do is I'll just explain to you what's inside the machines, because some of the problems that people have been having is air locks, air ingression, which causes corrosion inside the machine, air locks and then contaminated water, which causes a bacterial infection inside the machine, which then ups the pH of the coolant which is supplied to above 9, which makes it become an acid. It eats the machine away, and then what it will do then is it creates copper sulfate with a reaction with the copper and the oxygen in the water, which in turn blocks the pipe up the back and stops the machine working. We can clean them out. We've been cleaning them out for other companies that have been having similar problems. Mainly it's down to the positioning of the coolant manifolds on the back. It's different makes, some of the manifolds are slightly different. We always keep our manifolds way up in the air, and I've now got a header tank on them to increase the fluid storage. But if I go through, I'll show you. Now inside the machine, you have your induction coil on the front. On the back you have the water takeoffs. You've got 3 in, 3 out and 1 in. Some machines have 6, totally depends on the make, but the ones we sell, our machines always have 4. Now this is the coil inside the machine. You have one coil winding inside the other. They're tubular. The coil creates an inducting circuit in the front which in heat and turn heats your metal. Now when you look at the position of where the coolant pipes go, the top of the head, if you follow along, it's higher than the outlet on the back, it's here. Now some problems we've noticed which people have been having is they run the pipes down and under and they create an airlock. In the top here you cannot tell, the pipes are full of coolant, but it creates air in the top few pipes. We've put a camera down and had a look. This in turn heats up, creating a still, and it can distill the coolant. Well, it's all right if you're making whiskey, but what it does is, because there's oxygen in it, causes corrosion. It's a sealed system. You should not have air in a sealed cooling system. Right, we've been running our machines now for several years. And if you look at the big machine over here, look, this is a 40 kilowatt. This is the same coolant. It's been in here with our low loss header and coolant pump. This is the same coolant that's been in here 5 years now. Perfectly clean. Occasionally you get a small piece of air, but that comes straight out when you turn it on. I've got a bleed nipple on the top. Now a telltale sign if you're getting a bacterial infection or air ingression into the system is the pipes fur up. And this is the copper sulfate build up on the outside of the pipes. You do get a very small amount, but this is excessive. And you can tell whether you have a problem, whether you're stirring air into your coolant. Now we've been recommending serving the machines every 1 or 2 years. We'll service it for you, we'll clean it out and then check the pipes and put them back, or you can do this yourself. But you will soon see, if you can always contact us if you've got a problem and it's not one of our machines and you want help, you're more than welcome to phone up, we'll go through things with you. There's lots of safety points on the machines. If you turn the machine on and you have no water supply, an alarm will come on and it will say water lack. If your machine is overheating, it will go over temperature and it will turn off. Now, because the pump is supplying several cooling systems, it is possible to block one pipe and the coolant still be circulating around the machine. So they do need checking. Each year I'll just check the back of my pipes and I'll just make sure they're clear. Now, you don't have to use our recommended coolant. Some people have used mountain spring water. That is entirely up to them. If it's in the winter when it's cold, it will freeze and destroy the machine. If you run tap water through the machine and you're in a heavy water area, your machine will scale up like a kettle. So you're better off using the recommended coolant, and then you're safe. It's anti-freezing, the coolant, and anti-corrosive. Right, I'll turn the pump on. Straight away, the water lack light comes off. There's a little micro switch inside the machine which tells you the pressure. Now, when we run our machines, I always have the manifold up high. It stops you getting water leaks, air locks in the water. Now, another thing that we've found that can happen, because we can't make out how some people have problems, and we've sold hundreds of the machines and loads of them last years and years, no problem. The other thing which can cause air ingression into the pipes is if you let the header tank run out. So you can easily tell if your coolant is working properly. I've touched the coils directly after I've heated a bar and they're cold. If your cooling system is starting to block up because you've got a fault, these coils will start to get warm, and then you'll see, you'll realise what it is. Right, this is an easy way of filling the system and emptying the system if your TIG cooler's down low. Now, when this is running, you can undo the sealed cap and you can top it up if it's low. As soon as you turn it off, it will start unloading back into the tank. So don't try filling it with this off, but that can fill it. Now, if I empty this unit, I'm just testing this out of water because I'm just flushing the system through. When we test our induction heaters, we use water and antibacterial and we'll flush them through and try the system. But when you want to fill the system up, because your radiator's up here, if you undo the plug, it takes hours trying to fill it up with a little can. You can fill it up through the pump. So if you turn the pump on and then just keep filling this tap, keep filling. Now you can see air ingression in it because there's no coolant. So just keep filling him up and it will go through the whole system. It will take all the air out. I'll leave the pump running, then I'll bleed the radiator. There it goes, it's now got the airlock out of the pump. Away goes the air bubbles. Now the radiator's full. If the pump, when you first start it, is making a funny noise and it's not pumping, what we normally do is I just blow back down the pressure to get the airlock out of the pump, and then away it'll go. Now I'll fill it back up, you can fill it right to the top. So the air bubbles have all come out. I'll keep filling it. It will take them all out completely. Now if you turn the pump off, you're going to get a back pressure. It'll start draining it. So you need to seal it up now. So I'll seal him up. Turn it off. You've got a complete system, no air, sealed. If you accidentally, when you change the coils on the machine and put the coils on, they're going to have an airlock in them. If you get air around the system again, it will rise to the top of the radiator. So we're using this as like an air filter as well. So any air will come to the top, the water's going through there and out there. You can bleed it off the top. It really improves the usage, because we've found problems where people are not getting the air out of the machines, and this is what helps solve the problem. Now this is a machine that's just come back for service, and we've connected a low loss header to it, and he had a problem. He had a small blockage in the pipe and the coils got hot, so we flushed him through, service machine. It's been running about a year. Now another thing you can do, which if you're running more of an industrial flat out all day every day, you can add 2 radiators and link them together. Or you can also use an industrial cooler, but they're a lot of money, like £3,000 or £4,000 for even the smallest ones. Laser coolers will do it. Or you can build your own on a big header tank. But people are inventing loads of different ways of doing it, but it's up to each individual. There's a few more issues we wanted to address to help all our users and everyone on YouTube. The other problems people have with high frequency induction heating is the coils must be matched to the machine. So generally speaking, a 20:1 machine is normally an 800 to a meter long coil winding, and a 20:2 is 1500 to 2 meters, 1800. And you'll see if the coil doesn't match the machine. What the machine will do is it will just stay on low frequency all the time. It will not swap over to high frequency. Also, we recommend you use thick wall copper coils. Some people have used brake lining or brass pipe. It's not really recommended. If the electrical conductivity is slightly different, it could affect the warranty on the machine. It could mess the machine up. And stainless steel coils are just a no-go really. There is other problems which do occur as well. There is an over voltage light on the machine and an over current light. Now an over voltage light, if you put the machine on your 3-phase supply and you're on a farm and they start up some massive high draw corn drying system, or someone's welding on one line and you have a line imbalance, the over voltage light will come on and the machine should cut out. They also are not very generator friendly. If you run them on a generator and it spikes, it will blow the machine up. So I don't run mine on a generator, whether they say they're generator friendly or not. They recommend do not use them on a generator. Also, the other issue is cover the machine up. They are high frequency inside. If you work with grinders and you have your machine next to a grinding bench and it fills up with grinding grit, it will have the same scenario as inverter welders. Well, it will run perfectly all right, and then all of a sudden it will start cutting out on an overload. It phosphates inside and you'll see little sparks appearing inside where all the grinding grit is starting to spark out. When we service the machines, we always blow them out. I don't use a high pressure airline. I'll show you the best thing to use. We use a high volume, low pressure leaf blower, look. That will tidy the workshop out. It'll blow dust out your welder and all your machines and electric motors, but it doesn't blow the insulation off all the diodes and electrical components inside. This is our 40 kilowatt machine, which I'm using. And if you look, I've never run in it flat out. It's so powerful. It's about 3/4 of the way up. The smaller machines, I do run these on maximum. They will run on maximum, but I try not to run it on maximum all day. If I want to heat a small bar and save electric, I use a smaller machine. If I want to heat bigger bar, I'll use the bigger machine and turn it down. So the moral of this is to help you choose your induction machine which you purchase. Always go for the biggest machine you can afford and the biggest machine for the job. So don't try to buy a tiny machine, run flat out, continuous. They will run flat out. If you do, you've got to improve the cooling system on them. So the same thing as if you want to drive around Route 66, don't do it on a moped, buy a Harley Davidson. So there you have it. I hope that helps a few viewers out there who've got different machines and some of the do's and don'ts with induction. I will be doing some more filming and we'll do some bits on different coils, and if you look through YouTube there's loads of tutorials on there on how the machines work. And if you have any good ideas as well, contact us, tell us. Alright, thank you very much.